So you've heard the name Ethereum, right? You've probably seen the price go wild, and you hear it mentioned right alongside Bitcoin. But what is it, really? Well, it's a completely different animal. In this explainer, we're going to pull back the curtain and really get to grips with Ethereum, this idea of a single global computer for everyone. All right, here's our game plan. First, we'll look at how Ethereum took the idea of Bitcoin and just ran with it. Then we'll get into its secret weapon, smart contracts. After that, we're popping the hood to see how it all works. We'll figure out what it actually costs to use this thing, and we'll end with a pretty wild story that split the entire community right down the middle. Okay, so to really understand Ethereum, you gotta start with what came first. Let's nail down the key difference between the two biggest names in the game. Think of it like this. Bitcoin, which came out in 2009, was absolutely revolutionary. It's like a global public spreadsheet designed to do one thing and do it incredibly well: be digital money. It's a purpose-built calculator. But then Ethereum came along in 2015 and asked a bigger question. What if this blockchain thing could do anything? Instead of just a ledger, it's a fully programmable computer that anyone can use. And that brings us to this pretty dense definition. I know, it's a mouthful. But the only words you really need to focus on are distributed computing platform and operating system. All that means is it's a foundation that people can build stuff on top of. And the fuel that makes this whole computer run? That's its currency, Ether, or ETH. So how in the world does a blockchain become a programmable computer? Well, the magic ingredient, the real game changer, is something called a smart contract. Let's break down what that actually is. A smart contract is really just a fancy name for a program that runs on the Ethereum blockchain. But here's the kicker. Because it's on the blockchain, it's not on some company's server, it's everywhere. The rules of an agreement are just written into the code. And once it's live, it just runs automatically, exactly as it was programmed. No one can stop it, no one can change it, and there's no middleman. And these simple little programs, they unlock a whole new universe. They're the reason we have decentralized finance, or DeFi, which is trying to rebuild banking without the banks. They're what make NFTs possible, giving us true digital ownership. And they power DAOs. Think of them as organizations that run on code. But the coolest part is that they're composable. That means apps can plug into each other, like digital Legos, creating this explosion of innovation. But this brings up a huge, huge question. If these things run on their own and can't be stopped, what happens when the code is wrong? What if there's a bug that lets a hacker drain millions of dollars? Who fixes it? Who's in charge? The answer to this gets to the very core of what Ethereum is. So to answer that, we have to go one level deeper. We need to look at the engine that's actually running all these smart contracts and keeping this global computer humming along. You see, all those thousands of computers around the world running the Ethereum software, you can think of them all acting as one single shared computer. We call this the Ethereum virtual machine, or the EVM. It's the environment where every single transaction gets processed and every smart contract actually executes. You know, people joke it's the world's slowest computer, but its real power is that it's unstoppable and shared by everyone. The EVM really only has one big job: keeping track of Ethereum's state. Now, state is just a fancy word for a snapshot of everything. Every single account balance, all the data in every smart contract, all at one moment in time. When you send a transaction, you're basically sending an instruction to the EVM. The EVM runs it, and the snapshot updates to a new state. That's it. And every computer in the network has to agree on that new state. And this is a really important difference from Bitcoin. Bitcoin basically tracks every single tiny piece of Bitcoin, like digital cash. To know your balance, your wallet has to add up all the little pieces you own. Ethereum's way simpler. It uses an account model, just like your bank account. You have a balance, and a transaction just moves value from one account to another. It seems like a small detail, but it makes building apps way, way easier. Right. So running a world computer isn't free. Every calculation, every piece of information you want to store, it all has a cost. So let's talk about how you actually pay for your slice of this giant computer's time. To do literally anything on Ethereum, you have to pay a fee, and that fee is called gas. It's the perfect analogy, really. Your car needs gas to run, and the Ethereum network needs gas to process your transaction. The total fee you pay is based on a few quick things we're about to cover. First up is the gas itself. Gas isn't money. It's a unit of measurement for how much computational work something takes. A simple transfer might always cost, say, 21,000 gas. A really complex transaction could cost millions. Every little operation has a fixed gas cost. Okay, next is the gas price. This is what you're willing to pay in Ether for each unit of that gas. So think of it as the price per gallon. This price goes up and down depending on how crowded the network is. If a lot of people want to make transactions, they'll start bidding up the gas price to get included faster.
And finally, you set a gas limit. This is your safety net. It's the absolute max amount of gas you're willing to let a transaction use. Why? Well, it protects you from a buggy smart contract that could get stuck in an infinite loop and just drain your entire wallet. Any gas you don't use gets returned to you.
Now, this whole fee system got a massive overhaul back in 2021. The old way was basically a wild auction. You just placed a bid, and if you bid too low when it was busy, your transaction could get stuck for ages. It was a mess. The new system is way smarter. It has a predictable base fee that the network sets automatically. Then, if you want to, you can add an optional priority fee, a tip, to cut in line. It just makes fees a lot less of a guessing game. And here's the most mind-bending part of that upgrade. That base fee doesn't go to anyone. It gets burned. Poof, gone forever. It's permanently destroyed. This creates this incredible economic twist. The more people use Ethereum, the more ETH is removed from the supply. If activity gets high enough, more ETH can actually be burned than is created, making it potentially deflationary. Its total supply could actually go down over time. And all this brings us back to that central idea. Ethereum is run by code, sure, but it's also run by a community of humans. So let's finish with a crisis that put this whole system to the ultimate test and literally ripped the blockchain in two. Way back in 2016, this huge project called the DAO got hacked because of a bug in its code. An attacker started draining tens of millions of dollars worth of ETH. It created a massive crisis and a huge philosophical fight. One side, the majority, said we have to step in. Let's rewrite history, reverse the hack, and make everyone whole. But a really passionate minority said no way, code is law. The whole point of a blockchain is that it's unchangeable. You can't just undo things you don't like. The two sides just could not agree. So they did something almost unthinkable. They split the chain. The majority went forward with an upgrade that reversed the hack. That's the blockchain we all know as Ethereum today. But that minority group? They refused. They just kept running the original, unchanged version of the software, the one where the hack is preserved in history forever. That chain still exists today as Ethereum Classic. And that story just perfectly captures the tension at the very heart of Ethereum. The DAO hack forced everyone to make a choice between cold, hard code and messy human consensus. It really makes you think, what is a blockchain supposed to be? Is it this perfect, unchangeable historical record, no matter how ugly? Or is it a tool that should ultimately serve the people who build and use it? There's no easy answer, and that's the debate that continues to shape the future of this whole space.